Hello, this is NixOS Discovery, and I'm gonna go back now to the NixOS modules deep dive that I began, and that I kind of began working through the djacu. I'm not sure how you pronounce this, djacu, jacu. I don't know. He wrote this like a bit updated. I mean, there is the oh look, contributors Yorick Sar. He comes always to Infinicil's Nick Sauer. So Infinicil wrote this on NixDev. There is this modules deep dive that Infinicil wrote, and then djacu suggested some improvements, and he wrote a different one that is kind of like self-contained because Infinicil used a like a library or something, like a Google Apps, Google Maps, something, some kind of an app. Well, to teach some modules concepts. So djacu, probably I'm going to link this in description. djacu has a nice video where he actually goes through the module. I saw the beginning of it, and I've just thought I'll just go through it like I did with the NixDev, and at my own pace. She's trying to, my cat. She's trying to rip the couch. No, okay. A basic module. Okay, what is a module? Module is a function that takes an attribute set and returns an attribute set. So this kind of definitions we see a lot in functional programming. So it's defined. So it's already like it's a function. So it's a function that takes something and returns something. Yeah, this is I've been trying something with NixRepl. So it's like the X. The X is like the id like, well, let's call it identity, is a function that takes an S and in the body returns the X, right? So then identity 2, we get a 2, right? Identity, will it work like this? Yes, it returns an empty. So a module is a function that takes an attribute set and returns an attribute set. So basically it's still a function. It may declare options and it may define option values. Now these options, and later we'll get to config, produces, it's, I think that what I saw, I don't remember now, I saw it in an interview with one of the NixOS, with one of Nix developers, and these are like leftover terms. The module is that's an okay term, but the options and config, which we will see, it's kind of like from old times. Okay, this is not clear. I'm just going to continue. So it produces a configuration based on the declarations and definitions. The format is like so. So useless Nix. So useless Nix. Wait, let me remove this. So I'm going to go into code. Oh, this is what I've been doing. Yeah, okay. I'm going to make NixOS modules lesson, and I'm going to cd into that, and I'm going to write now useless.nix. Well, let's make it even bigger. Okay, so the format is like this. So this is like called useless Nix because it's an empty it's completely empty. So it takes an empty set, an empty attribute set as arguments. So look, it takes an empty argument set and the body is empty itself again, right? So it takes, so let's write it, 3 dots. So that's the so-called ellipsis. Wait, but I think the ellipsis takes in, like, it means that it can take an arbitrary number of arguments. We'll try it later. I'm not sure if it will work without the ellipsis. So look, this is the useless.nix. This is a module. This is a module. Okay. So if I save this, how do I see if this works? Let's add this to make it a bit more useful. Wait, but I want to check how do I? That's not written in the lesson. How do I check? How do I eval just the useless.nix? He did write like a bit more complicated eval function, but I want to see something much simpler. Nix instantiate. Nix instantiate useless.nix. All right. So nix instantiate useless. What do we get? Nothing. Nix instantiate useless.nix. Code module lesson. Nothing. Can we pass it? Wait, if the file is valid, it will return a result showing the path to the DRV file, or just confirm that it evaluated successfully. So it's successful because it showed the path where it's located. Since useless.nix doesn't define anything meaningful, you will get a path without much detail. All right, so it works. That's our first module. All right, that's the end of the lesson. No. Oh, this is horrible with ChatGPT. With NixEval. You can also use NixEval to evaluate the file, but since your module doesn't return anything useful, you would need to modify it slightly to output something. For example, if you want to output a simple value from the module, modify the file to something like this. You can give it a value, hello Nix. So this is not without the types. Yeah, he already introduced a type. F NixEval, useless Nix value. But what's the NixEval? Wait a second. NixEval does not contain a flake.nix. Searching up, could not find a flake. NixEval, useless. Yeah, we don't have a flake.nix. I don't have flakes enabled. I've enabled the Nix commands, but somehow some of these commands are not working without a flake.nix. Should I make a flake.nix? Could that work? Because I want to evaluate, well, can we, well, let's see now. You see, this is already interesting now. I'm going to try useless Nix, and within the body, value hello Nix. What if I just, can I just give it a string? Okay, value, let's try this. Hello Nix. Hello Nix. Yeah, this is correct. Value at hello Nix. All right. Now, if I run again NixEval, Nix instantiate, no, nothing is happening. Value, error getting of Nix instantiate. Wait, could I do like maybe strict? No. NixEval. This is not working, the NixEval. This will return hello Nix. Direct parse. If you want to validate the syntax and see if the file is correct, we have parse. I thought with strict, yeah, but it's not, no, strict is not, this was not correct. This was not correct. Oh, parse. Yeah, strict is lazy. If I had strict, oh, this is interesting. Value hello Nix. So if I had, let's say 2 plus 2, aha, all right, let's try something. Wait, value is, this is a string, but what if I, could I Could I do like 2 plus 2 plus 2? Will this work? 2 plus 2, right. And if I add strict now, will I get 4? No, I will not get 4. Why will I not get 4? Because I only have a value. The argument, yeah. I guess if I added here like, maybe if I add here an x, and x is 2 plus 2, does this make it, is this even, is this even correct? Oh, x is 2 plus 2, parse strict. Yeah. Not sure. Let's get back to our, oops. So value, hello Nix. Nix instantiate. This checks, let me know. All right. So, okay, let's just see what he did then. As the file name suggests, it's completely useless. It takes no arguments and returns an empty attribute set. However, it is a valid module. So what if we just remove this, right? Like we had, and we use Nix like this. Oh, now we see it. All right, without the strict. Yeah, and without the parse, we get the path. All right. Yes, this is why, I mean, watching a tutorial is great, and maybe what I'm doing now, it's a bit, you know, it's a lot, but okay, I'm commenting, but this is how I learn. So, and it's important to try things out, even to like try some of the things you already know within another tutorial, because each tutorial somehow, it doesn't take the shortest path, but it's composed. The problem when you compose something, you don't run into stuff like this when you it seems like you're improvising. So it's not bad like to take a composed lesson, a long one such as this, and then try stuff out within, and then move along the pace of the lesson. That way you won't get stuck. So, but maybe, you know, okay, it takes no arguments, returns an empty attribute set. However, it is a valid module. Let us add to this to make it a bit more useful. Am I recording? I'm recording. To define any, I have to see if there is a way to like smooth scrolling. Do I have smooth scrolling? Smooth, let's see. Yeah, I don't know, will that even change anything? I'll see. Auto scrolling, smooth scrolling, I don't know. To define any values. To define any values, the module system first has to know which ones are allowed. This is done by declaring options that specify which values can be set and used elsewhere. So this kind of options word, I think it's like a left over from C or something. me as someone like learning Haskell, it's not clear to me what this means. This is done by declaring options that specify which values can be set and used elsewhere. Options are declared by adding an attribute under the top-level options attribute. The most general way to declare an option is using libmk option. Yeah, this is like, okay, what is the equivalent in Haskell or functional programming for this term? Options, because I heard in a Nix interview that options and config is an older term left from C programming. So the term options refers to the configuration settings that a module can declare and define. These options specify what values are configurable in the system, what kinds of data functionality. Haskell, which is also a functional programming language, there isn't a direct one-to-one term for options in the sense of, yeah, NixOS configuration. However, certain Haskell concepts are analogous to how options are used. The closest concept to NixOS options might be type classes or data types. These define what values are allowed for certain configuration, much like NixOS options declare what types of configuration files values are valid. In NixOS, you might declare an option with a specific type, some option, and then type, it has this type, and the default value is false, and the description an example option. Right? So this is like when you, so these are like, I guess, options within programs, you know. In Haskell, this is similar to defining a data type with certain constraints or defaults. Data config, some option, default why is config used? Config is the equivalent of the NixOS options declaration, and default config provides a default value. Yeah, this is not clear. Algebraic data types. In NixOS, an option might declare that a certain value is either true or false. A Boolean, yeah. That's like the options in editor, or when you make a module that would control a part of your system, and the default value is false, and you set it to true, you know. In Haskell, you would use an algebraic data type or something similar. Data bool option, true option, false option, records. All right. Options. So we have a useless.nix, right? We have a useless.nix. Now we're going to create options.nix. So we have to have a new file. So we're going to have now, now we don't have any more an empty. So we have a, what do we have? A lib, and we have a lib now, and options. What do we have? Now another attribute set. So option is an attribute set within the empty attribute set. Well, it's not empty now, it's full. Name, I'm just not sure if the useless was an example and now we'll just have options in config, or we need the empty module. I guess we don't need it. That was an example. That's not clear. Options. So we name it. Okay, we name the option. But we don't really name it. We just invoke libmk option. Not sure. Libmk option with a type. What? Lib types. There's a lot of, why do I have to write lib so many times? I do not like this. So yeah, libmk option, lib type string, libmk option, lib type. All right, so we have options. While many attributes for customizing options are available, the most important one is type, which specifies which values are valid for an option. There are several types available under libtypes in the Nix packages library. Let's check it out. Types bool, these are just the basic types. Bool by or, true or false, path. If any of multiple definition is true, definitions are merged with the logical or. This is interesting. A path, it's a type. Anything that starts with a slash is a type. Okay. Types path in store, a path that is contained in the Nix store. Oh, the path in store. So any path but that is contained in the Nix store. Packages, enum. So we have some types. Well, that's cool. We have some types. Anything. Interesting. Types raw, numeric types. These are all numbers, string types, lines, commas, submodule types. Yeah, but you know what would be union types? Either T1, T2, one of. That's nice. Some types, attributes, attribute tag. Oh, I think Hensing or who introduced this? Lib inherit lib type mk option in options store router. This will be interesting. Yeah, there is an Infinicil NixOS episode where he covered this. Yeah, that would be interesting to check. Composed types, submodule. Some of these are very, some of these are mathematical and some of these are just, just basic types that kind of group things. As you can see, we have declared an option name. So the option name, we have specified that the name option will be of type string, so the module system will expect a string when we set a value. Okay, so that was my mistake. I said like the option that have a name, but you don't write a name. You always define things. You will give it a name later. Yeah, you don't put any values here. There are no values here. So there is an option. The option will have a name, and it will be its type of that will be a string. Right. As you can see, yeah, we have specified that the name option will be of type string, so the module system will expect a string when we set a value. Well, it's a lot of typing, yeah. Or maybe not. You may have noticed that we have also changed the function arguments. Now the module is a function which takes at least one argument lib and may accept other arguments expressed by the ellipses. So this tells us that the useless.nix is, we don't need that. That will not be essential or important. We can delete useless.nix. It was just an example. This will make, it was example of an empty module. This will make Nix packages library function available within the function body. We needed this to get access to mk option and types. So we need the lib here in the attribute that we can access these guys. We need this to access these guys, and we need these guys string. We need name to access to give it a value, and we need a type as string, so that is a text. So these are nice types, right? Otherwise, yeah. Let's just go on. You may have noticed that we also changed the function arguments. Now the module is a function which takes at least one argument. Okay. No, the ellipsis is necessary because arbitrary arguments can be passed to modules. Every module should have this. So every module should have an ellipsis in the end, right? So if you look, so the same thing, well, I'll just, so the same thing we have at, right? The same thing we have here actually. If you look at your etc NixOS configuration.nix, it looks like that empty module. So this itself, the configuration.nix, the file itself is a module that as its attributes takes the config and packages. And then there is the ellipsis, and you see it looks the same as the useless.nix. And here is the body. So the body of the entire module, and here it's the end, you see? So the body of this entire file, that's the module. So that, I remember this was like a mind-blowing moment, right? But the file itself is a module. And here imports, like, because I thought this is like a text file and the modules are imported here. I mean, it's somehow, I think it's kind of like a conceptual, I don't know how you call it, but it's I think it's like a common mistake. Like you start with a file and then from that file you call stuff. But the file itself, so it's very functional in that sense. The file itself is a module. So the entire system is like a giant module. So it's like modules all the way down, or like the turtles all the way down. So, okay, but here we have config and packages. Bootloader. Do we have like a config here? Services, you see? So these are like module options. You see this true, these are all options. And the name of this, I guess you could look at the code of this, like the code. These are like, I guess these are like sub modules. If we look at this, services, server, and enable true. So these are the various options that this submodule can have. And this can enable or disable. So that's the power, I guess, from NixOS, because you don't have to directly go to this, I don't know, like I remember in another distribution, you have to know the command of this or that. So someone writes a module and incorporates the commands, or however you do, however, whatever the subcommands are, or how it works, and writes a module. So, and then writes submodules, right? This, so everything's like lined up, true or false. So you don't have to know all these commands. You can just enable them. In that sense, it's really functional, right? Yeah. Services, server, enable true. Yeah. And this is how you can write also modules for things that are, that don't exist yet, like programs, or, some programs, or like frameworks, or that you can define them with this and then use them in NixOS. In that way, the NixOS is very powerful. True. Yeah. Okay. No. So additional permissions. What is this? Request permission. What did I do here? Plasma search. I think this is plasma integration. Hello. Okay. So the lib argument is passed automatically. All right. Now that we have declared an option, we would naturally want to give it a value. Okay, now it's time to give it a value. All right. Options can be set or defined using another top level attribute config. So now we're going to give it a value. How long is this video? So this video is already 29 minutes. I think the video that I watched was like, at this point, it was like only after like 10 minutes or something. Well, I don't know. But this is way longer. I think this will be a long tutorial. But for me, this is a good rhythm. Now that we have declared an option, we would naturally want to give it a value. So now let's give it a value, right? Another top level attribute config. So we have what do we have? Yeah, ls. So we'll just remove the useless.nix, and we have options.nix, right? Options.nix. And now we're going to write the config.nix. So now we're going to, again, we are entering an empty attribute set. Why are we entering an empty? Let's see. You see, an attribute set. Now the body itself will be config is what? Okay, config will be, config, name. Name is what? Boaty, make boat face. All right. So now we have config, boaty, make boat face. Now let's see now. Previously in our option declaration, we created an option name with a string type. Here in our option definition, we have set that same option to a string. So options and config and have formal names. This is okay, like a typo. That is option declaration and option definitions, respectively. The rest of these lessons will use them interchangeably. I guess this is how so option declarations and option definitions. So functionally speaking, I guess a better name would be a declaration and a definition, and not option and config. Config is just, I don't know what's config, right? It's still like with config, you configure a definition, and with an option, you declare your options and you define your configuration. Yeah, you declare an option and you define an configuration. So it's called option declaration and option definitions. Yeah, I don't know why they can't change this. Maybe it's too complicated. Yeah, sometimes changing little things is a lot of work. Note, our option declarations and option definitions do not need to exist in the same file. Yeah, when we evaluate our modules, we can simply include both files and log as every definition has a declaration. Now he's using only definition and declaration, as long as every config has an option. So every definition is inside. So config has definitions and option has declaration. We can successfully evaluate our modules if there is an option definition that has not been declared. The module system will throw an error. So let's use option definition and config declaration. Option declaration and option definition. Oh, yes, you see the options and config, that is option declarations and option definitions. So option definitions is config and option declarations is options. This is confusing because, yeah, if there is an option but I want to paste this. Why? Like, we have an empty attribute list. Okay, why is there an empty attribute list in the config.nix? The empty attribute list in config is a common idiom in NixOS to represent a function that accepts an arbitrary set of arguments and returns an attribute set, in this case config name boaty make boat face. Here's why the empty attribute. Modules and functions are often defined as functions This function can take any number of arguments. The ellipses take any arguments. This means the function is flexible and doesn't enforce or rely on specific input arguments. Instead, it's saying, I'm prepared to accept any set of arguments passed in. Because, okay. So the module body. Input. This is a function that can take any number of arguments, but it doesn't directly use them. And output. Okay, it's needed, yeah, because it follows a declarative functional programming style. Configurations are generally represented as functions that produce configuration set. So the empty attribute set, so with the ellipses that takes any number of arguments, keeps this function signature uniform and ensures compatibility within the Nix module system. Okay. Now that we have our declaration and definition, how do we evaluate them? There is a function provided by the Nix packages library, eval modules. It takes an attribute set as an argument, and one of the attributes is modules, which is a list of modules you want to merge and evaluate. So before we use Nix instantiate, and there is now eval modules function. The output of eval modules is a rather large attribute set with the information about all the modules. For now, the attribute we care about is config, which is where the final configuration values appear. Eval.nix. Can we use like just eval? We can create a helper script to parse and evaluate our eval.nix and print the output in a nice format. Eval.nix. Eval modules. How do I use, because he's like writing the eval.nix. Okay, let's try it, but I'm not sure. Okay, there is an empty attribute set, but now we don't, this is interesting, now we don't have an attribute set. We have, what do you call it? The not bracket, but parentheses, yes. Packages, libeval modules. Maybe because it's calling something, not sure. Modules, options. So now we're gonna call config.nix. All right, config.nix. Okay, and well, we can create a helper script to parse and evaluate our eval.nix file and print the output in a nice format. Well, this is now too much. What is this run sh? If you execute the run file, you should see an output that matches what we have configured. Yeah, but I want to see something simpler. Look at this JSON. Eval modules. Okay. How do I eval this? Nix eval f config nix config name. Nix eval, but I cannot use Nix eval. It does not contain a flake. Let's try to instantiate options. Anonymous lambda without an argument, lib. Okay, let's in Nix instantiate config. Let's Nix instantiate eval. As top level, this case it must have arguments supplied. What is this? A Nix expression that evaluates NixOS modules using the eval modules function, which is provided by the Nix packages library. Argument packages. Takes an argument packages, which is typically a reference to the Nix packages package. Packages provides access to various libraries. Okay, so we need packages in an attribute set so that we can access lib or like eval modules. So before we put lib, but now we are putting packages. So is this like a superset? All the packages? Packages lib eval modules. Eval modules is a function found in the Nix packages library. Packages lib. Oh, so this is a subset of lib. It's used to evaluate NixOS style modules. Modules in Nix are declarative sets of options that define configurations. Modules input. Modules are these two, right? The modules. Purpose. Name boating McBoatface. So why is in the eval.nix parentheses used as the body after the argument attribute set? Because we don't have, right, let's see. Nix eval. Can I use Nix eval? Will this even work if I copy this? Well, let's try. Parentheses are used to group expressions together and control the order of evaluation. Oh. So in your example, parentheses are used after the argument attribute set to group the body of the function. Here's the example again for clarity. Yeah. Why use parentheses? Ensure that the function body is evaluated as a single expression. Attribute set. So, yeah, this was clear. Function body grouped by parentheses. Inside the parentheses, the function body is this. So this is the function body, but it's inside the parentheses. This expression returns an attribute set, which contains the fully evaluated configuration. The parentheses make sure that the whole expression is evaluated before you access the config attribute at the end. Oh, that's why. Once the expression inside the parentheses is evaluated, the config attribute is accessed from the resulting attribute set. If you wrote the expression without parentheses, Nix would try to evaluate packages libeval modules config directly, which doesn't make sense. Yeah. We can create a helper script to parse. Well, let's see if this will actually work. Run sh. Okay. So we have run sh. If you execute the run file, run sh, you should see an output that matches what we have configured. Permission denied, run sh. Permission denied because it's a script. Do I have to like, how do I have to make the run sh executable? I put my eval, my Nix. Yes, if you want to run, yeah, make the script. I forgot. Chmod plus x, yeah. chmod plus x. Run sh. All right, let's try now. Yes. This is, so I need to have experimental. You see this? I need to use flakes, enable flakes for a single command. Nix eval extra experimental features flakes. Well, I could enable flakes, Let's try this. I'll just enable them. Okay. Let's see, NixOS configuration.nix and Nix settings. You see, but I have Nix command. Okay, flakes. So now NixOS rebuild switch. And probably after we do this, the run.sh, the script will work. So it's building. "46 minutes. All right. I'm still at the first page. Yeah. Building the system configuration. So yeah, now it's building. I guess it's building the entire system configuration. Validating. What is it doing now? Right? Will this thing work now? Oh, it's working. Look at it. It's downloading. What is it downloading? 43 megabytes. What did I do now? All right, 38 seconds. Let's try again. Yeah, now it works. Name boaty make boat face. So what does this mean? Yeah, this command is a sequence of Nix command with specific options for evaluating and transforming. So he's going to use the script djacu, I'm not sure, djacu, transforming Nix expression. Let's break it down step by step to understand what each part does. Nix eval. We have this apply function, x and x, the argument set and the body. So Nix eval, f eval Nix. This part of the command is evaluating a Nix expression found in the eval.nix file. So what if we just do Nix eval f and yeah, wait, what files do we have? Run sh option eval.nix. So nix eval.f eval.nix, it's a lambda. All right, so it's working. What if we do strict? No such file or directory. Will the previous parse work? No. The part of the command nix eval, this evaluates a Nix expression or a file. f eval nix, this f flag indicates the file that contains the nix expression. So this just indicates a file, dash file, which is in this case eval.nix. So it values the nix expression defined in that file. So what if we do like nix eval and the file is options, we get a lambda, and we have a config, we get a lambda. All right. And so now this is interesting. So this flag applies a transformation function to the result of evaluating the eval.nix expression. So apply this. Apply what? The apply flag takes a nix lambda a function. In this case, the function x is applied to result of eval.nix. Here is what this function does. Why is this thing not working? Arrows. X, okay, it's a function that takes x, the evaluated expression from eval.nix, and applies it passing the argument packages import nix packages. Imports the nix packages set. So this imports the nix packages set, which provides access to many packages and libraries. It binds the nix packages package set to the argument packages. So import nix packages, and here is empty. Okay, it's this, and binds it to packages. And that itself is within an attribute set. In simpler terms, this is applying the result of eval.nix and passing an attribute set, packages import nix packages, to it, making the nix packages library available within the evaluation. This flag specified that the output should be in JSON format. Okay, the pipe command, the pipe takes in the output from the previous command and passes it as input to the next command. Nix run, this is also new. This part uses the nix to run the djacu command, which is a powerful tool for processing and filtering JSON data. This runs the djacu utility, which is part of the nix packages package set. This is a complicated command. This separates options passed to nix from those. I mean, it's not, but it's kind of, I understand what's happening, but then it's, I can't remember now. Like, how does the command go? How does the script goes? Suppose eval.nix contains an expression that depends on packages from nix packages, perhaps to install or configure packages. This command evaluates the expression in eval.nix, supplies the necessary packages from nix packages, and then outputs the result in JSON format for easier parsing and further processing by djacu summary. Yeah, nix eval, f eval nix, apply. Can you make like a simpler? Maybe, I don't know, like a very minimal example of this run. Run sh eval nix version 1. All right, defines a module that takes packages as an argument, provides a configuration. Apply xx, I know. This is not what I meant. Can you simplify the run sh script into something more understandable? Or like apply 2 + 2 or something. And import a number from somewhere else. run sh number and eval. Minimal number.nix, create a number. Okay, we like numbers. Create a number.nix file. Okay, I just want to understand this script. Like, okay, let's make dir temp run, cd temp run. Okay, create a number.nix file that just exports a number. Okay, number.nix has a 4. All right. Now this number.nix file defines a simple numeric value 4, which can be imported and used elsewhere. All right, create an eval.nix. So create an eval.nix file that imports the number from number.nix and applies a simple addition operation 2 plus number. All right. That's clear, kind of. So number, that's the argument, all right? And, oh, let base value. All right. Let base value as 2. And now we have a let statement. And we're going to result is base value plus number. Okay, that's kind of clear. Yeah. So explanation. The eval.nix file defines a function that takes a number argument. In our case, that's 4. Inside it declares a base value of 2. That's just a random value. It then returns a set containing the result, which is the sum of base value 2 and the number imported from number.nix. So now we're going to run it. Oh, this is cool. Run sh. Oh, here's the simplified run sh script. So we're going to write now eval.nix. No, run sh. And we're going to write nix eval. Well, I guess we don't have to. Wait, let's try without writing a script. Let's just do it on the command line. So nix eval. And let's do eval. Wait, what do we have here now? Okay, we have eval.nix, which does the operation, right? And we have the number. So can we just write nix eval f eval.nix? We get a lambda. All right, but how will it needs to, we need to tell it what to do. We cannot just nix eval it. Nix eval it. Nix eval.f eval.nix. And now we have to apply what? We need to apply f, a function, and let's like the xx, yeah. Number import. Our number import number dot nix. And result is 6. So nix eval apply ff number ff number import number.nix. This is very functional. This is very functional explanation. So nix eval f eval.nix evaluates the expression in eval.nix. Okay, that's clear. I just want to run through this. Apply ff number import number nix. Applies a function f passing this to eval.nix, where number nix is imported and used. make run sh executable. Don't forget to make script executable. Running the script, result is 6. The eval.nix file imports the number from number nix, which is 4. It then adds 2 to this number, resulting in 6. The output is the result of this calculation. Result is 6. Summary. Yeah, this is kind of clear. What? It's 1 hour. Maybe I should stop now, and I'm just at the beginning. You see, but okay. If you execute the run file, you should see the output that matches what we have configured. But sometimes it's fine, like you try to understand things, and just trying to understand them, it's enough. You don't have, like, you can stop and then move on. But something remains, like a trace of this exploration remains. I mean, mind-wise, no. So, yeah. So now the next one is option dependencies. I think I'm going to stop here. I'm going to stop here, and that's it for today.